National Electrical Code Article 300.9 Protection from Abrasion covers the requirements for protecting insulated conductors from abrasion where they enter a raceway. Section O of this article states that where insulated conductors enter a raceway, the raceway shall be provided with a bushing designed for the purpose to protect the conductors from abrasion. This requirement applies unless the raceway is designed and constructed so that the conductors are not subject to abrasion at the point of entry. The primary purpose of a bushing is to provide a smooth, rounded surface at the conduit termination to prevent damage to the conductor insulation as it is pulled into or rests against the edge of the conduit. Abrasion can occur due to sharp edges or rough surfaces at the conduit end, potentially leading to insulation breakdown, short circuits, or ground faults. The code emphasizes the protection of insulated conductors. The requirement focuses on preventing abrasion, not specifically on the size of the conductors. While the code does not explicitly state a minimum conduit size that mandates the use of bushings, the need for protection against abrasion applies regardless of the conductor size. The exception to this rule states that a bushing is not required where a raceway enters a box or other enclosure designed to house conductors. This exception acknowledges that many enclosures are designed with smooth, rounded entry points or have integrated features that protect conductors from abrasion. The design of the enclosure itself provides adequate protection, negating the need for an additional bushing. Even though the NEC does not specify a particular conduit size for bushing requirements, it is generally considered good electrical practice to use bushings on all conduit terminations that are 1 inch or larger. This is because larger conduits often carry a greater number of conductors or larger gauge conductors, increasing the potential for abrasion during installation and operation. Furthermore, the larger the conduit, the more likely it is to have a sharper or rougher edge at the termination point. To ensure compliance and promote safe electrical installations, it is essential to inspect conduit terminations for any sharp edges or burrs. If such imperfections are present, a bushing should always be installed, regardless of the conduit size. There are various types of bushings available, including plastic bushings, metallic bushings, and insulated grounding bushings. The choice of bushing depends on the application, the type of conduit being used, and any specific grounding requirements. Insulated grounding bushings, for example, provide both abrasion protection and a means for bonding the conduit system to ground, which is crucial for safety. In summary, while the NEC Article 300.9 does not explicitly mandate bushings based on conduit size, the underlying principle is to protect insulated conductors from abrasion. It is a widely accepted practice to install bushings on conduits 1 inch and larger, and it is always advisable to use them whenever there is a risk of abrasion, regardless of conduit size. Always consult the latest edition of the NEC and local electrical codes for specific requirements and interpretations in your jurisdiction. The NEC serves as a comprehensive guide for safe electrical installations, and adhering to its provisions helps ensure the safety and reliability of electrical systems. In addition to Article 300.9, other sections of the NEC may also influence the selection and installation of bushings. For example, Article 314 covers outlet boxes, conduit bodies, and handhole enclosures, and it addresses requirements for conductor entry. Furthermore, Article 344 pertains to rigid metal conduit, Article 348 covers rigid PVC conduit, and Article 352 addresses electrical metallic tubing. Each of these articles may contain specific instructions or considerations related to bushings and conductor protection. When installing conductors in a raceway, it is essential to consider the full capacity of the conduit. The NEC specifies the maximum percentage of conduit cross-sectional area that can be occupied by conductors. Overfilling a conduit can make it difficult to pull conductors, increasing the risk of insulation damage and potentially negating the effectiveness of any bushings that are installed. Using the correct conduit size and adhering to fill limits is crucial for a safe and compliant installation. Proper installation techniques are also vital for ensuring that bushings function as intended. Bushings should be securely fastened to the conduit termination to prevent them from dislodging or rotating, which could expose the conductors to abrasion. The use of appropriate tools and hardware, such as lock nuts and bonding jumpers, is necessary for secure and reliable installation. In some cases, electrical inspectors may require additional measures beyond the minimum code requirements to ensure conductor protection. For example, in environments with excessive vibration or corrosive substances, inspectors may mandate the use of specialized bushings or other protective devices. It is important to consult with local authorities and adhere to any specific requirements or interpretations that they may have. The selection of appropriate bushings should also take into account the type of conductors being used. For example, some conductors have thicker or more robust insulation than others, and the type of insulation can influence the need for additional protection. Conductors used in high-temperature applications may require bushings made from materials that can withstand elevated temperatures without degrading or becoming brittle. Regular inspection and maintenance of electrical installations are essential for identifying and addressing potential issues before they become serious problems. Conduit terminations and bushings should be visually inspected for signs of damage, corrosion, or wear. Any damaged or deteriorated components should be replaced promptly to maintain the integrity of the electrical system. Proper grounding and bonding are critical aspects of electrical safety. Bushings that are designed to provide grounding continuity should be properly installed and connected to the grounding system. This helps to ensure that any fault currents are safely conducted back to the source, reducing the risk of electric shock or fire. In addition to protecting conductors from abrasion, bushings can also help to prevent the ingress of moisture and debris into the conduit system. This is particularly important in outdoor or wet locations, where moisture can corrode conductors and other components, leading to electrical failures. Some bushings are designed with seals or gaskets to provide a watertight barrier, further enhancing their protective function. When working with electrical systems, it is always important to energize the circuit before performing any installation or maintenance work. This helps to prevent accidental contact with live conductors, which can result in serious injury or death. Lockout/tag-up procedures should be followed to ensure that the circuit remains energized while work is being performed. Continuing on, the NEC provides detailed guidelines and the proper methods for grounding and bonding electrical systems. These guidelines are essential for ensuring that electrical equipment and enclosures are properly grounded, which helps to minimize the risk of electric shock and prevent the buildup of static electricity. Grounding and bonding requirements can vary depending on the type of system, the voltage level, and the location of the equipment. Electrical drawings and specifications should clearly indicate the grounding and bonding requirements for each installation. This helps to ensure that all components are properly connected and that the system meets the applicable safety standards. In addition to the NEC, other industry standards and best practices can also provide valuable guidance on electrical installations. For example, the National Electrical Manufacturers Association, or NEMA, publishes standards for electrical enclosures, raceways, and other components. These standards can help to ensure that electrical equipment is properly designed, manufactured, and installed. Continuing, the selection of the correct type and size of raceway is also crucial for ensuring the safety and reliability of electrical installations. The NEC provides detailed requirements for raceway types, including rigid metal conduit, electrical metallic tubing, flexible metal conduit, and non-metallic conduit. Each type of raceway has its own advantages and disadvantages, and the selection should be based on the specific application and environmental conditions. Factors to consider include the mechanical strength, corrosion resistance, and flammability of the raceway material. The NEC also specifies the maximum number of conductors that can be installed in a raceway of a given size. This is known as the conduit fill requirement, and it is intended to prevent overheating and insulation damage. Overfilling a raceway can also make it difficult to pull conductors, increasing the risk of damage during installation. The NEC provides tables and calculations to determine the appropriate raceway size for a given number and size of conductors. Proper labeling and identification of electrical circuits and equipment are also essential for safety and maintenance. The NEC requires that all circuits be clearly identified with their purpose and voltage. This helps to prevent accidental contact with live circuits and facilitates troubleshooting and repairs. Labels should be durable and legible, and they should be placed in a conspicuous location. In addition to circuit identification, equipment such as transformers, panel boards, and disconnect switches should also be labeled with their voltage, amperage, and other pertinent information. Continuing, electrical inspections are a critical part of the construction process. Electrical inspectors are responsible for ensuring that electrical installations comply with the NEC and other applicable codes and standards. They typically review electrical drawings and specifications, conduct site inspections, and witness testing of electrical systems. Electrical inspections help to identify potential hazards and ensure that electrical installations are safe and reliable. It is important to cooperate with electrical inspectors and address any issues that they may identify. Failure to comply with electrical codes and standards can result in fines, project delays, and safety hazards. Continuing still, electrical safety training is essential for all personnel who work with or around electrical equipment. Training should cover topics such as electrical hazards, safe work practices, lockout/tagout procedures, and the proper use of personal protective equipment, or PPE. Employees should be trained to recognize and avoid electrical hazards and to respond appropriately in the event of an electrical emergency. Employers are responsible for providing adequate electrical safety training and for ensuring that employees have the knowledge and skills necessary to perform their jobs safely. Continuing, the use of personal protective equipment is crucial for protecting workers from electrical hazards. PPE includes items such as insulated gloves, safety glasses, and arc-rated clothing. The type of PPE required depends on the specific task and the level of electrical hazard. Insulated gloves should be regularly inspected for damage and tested to ensure that they provide adequate protection. Arc-rated clothing is designed to protect workers from the thermal effects of arc flashes, which can cause severe burns and other injuries. The NEC requires that employees provide appropriate PPE and ensure that employees use it correctly. Continuing even further, electrical arc flashes are a serious hazard that can occur when electrical equipment fails or is improperly operated. Arc flashes produce intense heat, light, and pressure, and they can cause severe burns, blindness, and other injuries. Arc flash hazards can be mitigated by implementing appropriate safety measures, such as energizing equipment before working on it, using insulated tools, and wearing arc-rated clothing. Arc flash risk assessment should be conducted to determine the potential hazards and to identify the appropriate safety measures. The NEC contains requirements for arc flash hazard analysis and mitigation. Electrical safety audits are a valuable tool for identifying potential hazards and ensuring that electrical safety programs are effective. Audits should be conducted on a regular basis and should involve a thorough review of electrical equipment, procedures, and training programs. Audit findings should be documented and used to develop corrective actions to address any identified deficiencies. Electrical safety audits can help to prevent accidents and injuries and to improve the overall safety of electrical installations. In addition to the NEC, other organizations such as the Occupational Safety and Health Administration, or OSHA, and the National Fire Protection Association, or NFPA, also publish standards and guidelines related to electrical safety. These standards and guidelines provide valuable information on electrical hazards, safe work practices, and equipment requirements. Employers should be familiar with these standards and guidelines and should incorporate them into their electrical safety programs. Electrical fires are a significant cause of property damage and injuries. Electrical fires can be caused by a variety of factors, including faulty wiring, overloaded circuits, and improperly maintained equipment. Electrical fire hazards can be mitigated by implementing appropriate safety measures such as using arc fault circuit interrupters, or RFCIs, and ground fault circuit interrupters, or GFCIs, and by regularly inspecting and maintaining electrical equipment. Electrical fire prevention programs should be implemented to educate employees about electrical fire hazards and to promote safe work practices. Continuing with more, the NEC requires that all electrical equipment be listed and labeled by a recognized testing laboratory, such as underwriters' laboratories, or all. Listing and labeling indicate that the equipment has been tested and meets applicable safety standards. Using listed and labeled equipment helps to ensure that electrical installations are safe and reliable. Counterfeit electrical products are a growing problem. Counterfeit products may not meet safety standards and can pose a serious risk of electrical shock or fire. It is important to purchase electrical equipment from reputable suppliers and to inspect products carefully to ensure that they are authentic. Counterfeit products should be reported to the authorities. The NEC is updated every 3 years to reflect changes in technology and to address emerging safety issues. It is important to stay current with the latest edition of the NEC and to implement any necessary changes to electrical safety programs. Changes to the NEC can affect the design, installation, and maintenance of electrical systems. Continuing this discussion, electrical safety is a shared responsibility. Employers, employees, and electrical contractors all have a role to play in ensuring that electrical installations are safe and reliable. By working together and following established safety procedures, we can reduce the risk of electrical accidents and injuries. Remember that this information is general in nature, and you should always consult with a qualified electrical professional for specific advice on your situation. Staying safe with electricity requires constant vigilance and a commitment to following established safety practices. Electrical codes and standards are in place for a reason, and adhering to them is crucial for protecting yourself and others from electrical hazards. Always prioritize safety when working with or around electrical equipment. It is also important to remember that electrical work should only be performed by qualified and licensed individuals. Attempting to perform electrical work without the proper training and experience can be dangerous and can lead to serious injury or death. Continuing on, when working with electrical panels, it is essential to maintain a safe working distance. This distance, known as the arc flash boundary, is determined by the voltage level of the equipment. Workers should wear appropriate PPE when working within the arc flash boundary. Electrical panels should be kept clean and free of obstructions. Proper ventilation is also important to prevent overheating. Electrical panels should be inspected regularly for signs of damage or corrosion. Damaged or corroded components should be replaced promptly. Continuing, electrical outlets and switches should be properly installed and maintained. Outlets and switches should be securely mounted and should not be loose or wobbly. Cover plates should be in place to protect against accidental contact with live parts. Outlets and switches should be tested regularly to ensure that they are functioning properly. GFCI outlets should be installed in areas where there is a risk of exposure to moisture, such as bathrooms, kitchens, and outdoor locations. GFCIs are designed to protect against electric shock by interrupting the circuit when a ground fault is detected. Surge protectors should be used to protect electronic equipment from voltage spikes. Voltage spikes can damage sensitive electronic components and can cause data loss. Surge protectors should be installed at the point of entry of the electrical service and at individual outlets. Extension cords should be used only temporarily and should not be overloaded. Extension cords should be properly sized for the load they are carrying. Extension cords should be inspected regularly for damage and should be replaced if they are frayed or damaged. Finally, portable generators should be used safely and should be properly grounded. Generators should be operated in a well-ventilated area to prevent carbon monoxide poisoning. Generators should be connected to the electrical system using a transfer switch to prevent backfeeding onto the utility grid.